Hey everyone. So thank you for joining us. I don't know where you all are around the room, but feel free to drop it in the chat so we know where everyone is joining in from. So thanks for taking the time. And we're really psyched about, diving in now to prompt engineering and how we go about translating this art into best practices that we can then apply in our day-to-day work. So with that said, we're going to now introduce our speakers. And then we're going to dive into the interesting stuff that you're all here for. Awesome. So if that didn't give it away, one of our speakers today is Gad from TensorOps. We also have Miguel with us, who's also going to be diving into a lot of interesting topics. And from the Blattner Tech and Superwise side, David is going to be stepping in here and sharing a lot of his hard-learned experience with LLMs and prompt engineering specifically. So I can see a lot of familiar names here in the attendee list and in the chat. So I know that a bunch of you have already attended our previous sessions, but for anyone who's new here, just so you understand the context and where we're all coming from. So Superwise is a Blattner tech company. We focus in ML observability and monitoring, which is one of the key solutions that we have, but we also have additional solutions in the LLM and ML space. And TensorOp on the other side is one of the best boutique ML organizations and solution providers out there that I at least know. They have some interesting customers and deal with very interesting use cases. And they really focused on the last mile there. And that's where, the relationship between us comes into play. We're very product oriented, the best in breed of observability solutions. And TensorOp, as they bring their customers to that last mile of fruition with their ML and LLM solutions, has along the way partnered with us and is using our solutions there. And with that, I am going to hand it over to Gad. He's going to take you a little bit through the history of how we got here, and then we're going to open the can of worms, which is prompt engineering.
Yeah, thanks, Moran. So first of all, I'm excited to be here again in our third webinar in the series. The idea of this webinar series is to talk about how basically you can build applications with LLMs. So we started with a basic question, to train or not to train. And then we moved to speak about LLM architectures. And today we're going to focus on prompt engineering. What makes all of these, what connects all of these webinars is basically that while we thought that LLMs are going to be AGI and they're going to solve all of our problems really easily, and you just, have to just plug them into your existing AI applications or existing software applications, they turn to be a little bit more difficult to engineer and to incorporate. And all of these methods are about how to get out of LLMs what we want for our business use case. So in the context of how to train or not to train your LLMs, we introduced in one of the webinars a lot of concepts or a lot of techniques in order to do fine-tuning of LLMs. One of them was to basically do prompt engineering. So while we think of tuning your LLM as being maybe updating the weights or doing some human reinforced learning, this is actually something that doesn't require changing the weights of the LLM or the network. And just by constructing the right prompts, securing more consistent and more productive outputs of the LLM. So this is the context of what we're going to speak about today. Another way of doing this kind of fine-tuning is not touching the LLM itself, but basically building an architecture on it, which is the RAG architecture that we mostly spoke about in the previous webinar, and you can check it out. I think it has more than 30,000 views these days. So with that being said, I'm going to hand over to David to speak about prompt engineering as it kind of combines these two techniques, I would say. You're muted. Sorry, Dave.
Well, thanks so much, Gad. And everybody, thanks so much for letting me be here. Really appreciate it. And as Gad mentioned, in moving beyond this working definition of prompt engineering, going well beyond a simple RAG system, maybe leaning into fine-tuning, it's also helpful to articulate what prompt engineering is not. It's not simply this fail-fast environment in which there are no real directives or objective considerations for sharpening the stochastic output of an LLM. Even with these robust black boxes, there are some highly accessible points of entry involved, even if you may not have prior data science experience. For example, LLM performance evaluation, it's still nascent, but there are still some traditional natural language processing principles that are nevertheless at the heart of a lot of these well-curated prompt templates and overall infrastructures, and we'll hopefully cover all of those principles today. But with that being said, prompt engineering is also not simply a plug-and-play environment. It's very much has the staying power of, LLMs in the industry being the ways in which we can translate general solutions into something more specialized, something more narrow, especially with respect to how we deliver custom AI solutions to a wide range of audiences and a wide range of use cases. Now, how we deliver in this space will ultimately depend on countless LLM considerations in our use case and how we frame it, the complexity of LLM-based tasks required to meet that use case, some of the strengths and fallbacks of various model options in the market today, and ultimately how we continue to improve and optimize our prompts as the capabilities being used within them continue to mature in an ever-growing market. So prompt engineering, it falls within this general art and this general traditional machine learning capability into something along the lines of a discipline. So let's talk first about prompt design and development. We're going to be using a chatbot for air travel support to help us navigate all of our prompt capabilities, some of our basic principles, and as Miguel will talk about in just a few moments, some more advanced techniques that are emerging in the market today. But in beginning with the 5 core use cases, with problem framing being such a core part of it, it's oftentimes helpful to work backwards. So starting with the desired output, then talking about the workflow capabilities that you hope to work within your broader infrastructure, and ultimately the types of data connections and data sources that are needed to satisfy those capabilities within your overall workflow. Beginning with data transformation all the way up to agent ecosystem, there is a wide spectrum, and how you answer those 3 questions will ultimately dictate where you fall within this complexity spectrum. So let's start with data transformation. You have all of these traditional NLP and NLT capabilities that you would otherwise be able to satisfy through a chat style UA on top of a model like ChatGPT, for example. So summarizing flight information, doing sentiment analysis, and meta feature extraction, really anything that has this static input transformation to output structure. Natural language interfaces take that one step further and go from just extracting generative content to real information that's relevant to your business or your particular case. So in many cases, you might have a knowledge-based retrieval engine connected to structured data or unstructured documents, social media, etc. You may want to tap into something like a boosted enterprise search, or in this case of air travel, looking into Expedia, some flight carriers, any historical data on purchase behavior. Workflow automation is where we go from information to real action, taking actions on top of static end-to-end workflows or end-to-end systems that are otherwise really static and very repetitive. So each one has its ordered structure. Co-pilots, on the other hand, do not. They have to have more of a reasoning process, more of a step-by-step thought process to handle some more of these complex tasks that are just a little bit more ambiguous in how we generate them. In co-pilots, you can think about code generation assistance, in this case with air travel, a more advanced support chatbot. A lot of us are helping or being helped by co-pilots to generate our emails these days, moving all the way up to agent ecosystems or multi-agent systems. This is about as highly complex as it gets in the market today. We have a robust system that effectively takes humans out of the loop. So you're no longer making user requests. You have all of these agents interacting with each other to build on top of each other and provide some more complex use case satisfaction there. So with these 5 use cases in mind, from an architectural perspective, how do we satisfy a lot of these cases that we might anticipate in the air travel or in other potential industry cases? In the case of summarizing flight information, a simple prompt template, just plugging and playing with a simple prompt, ingesting some context through a user input and getting a response, it's probably going to be your best bet. In the case of prompt chains, however, you're mapping multiple templates together. The output of one just becomes the input of another. And you might want to use something like a vector database retrieval system through something like plain chain. That might be helpful here. A prompt chain template really incorporates a lot of the first two. So you're bringing in some prompt templates layered on top of one or more prompt chains to bring in from other knowledge bases like API calls, SQL, unstructured documents, pulling them all together in a more structured agent type way. And agents, much like as I mentioned, will take a lot more of a reasoning and thought process approach with prompt chain pipelines and prompt chains ultimately coming together. And much like with agents, bringing in those two, multi-agent systems will bring in a lot of other agents to work together to achieve whatever complex tasks matter most to you. So in many cases like this, several different models could satisfy the requirements of an LLM use case. So how do we differentiate them? Most of the answer falls within this two-dimensional spectrum. It goes without saying that constructing a multi-agent system for something like a flight summary would be a very poor allocation of your resources and really just a poor allocation of your time as a developer. And conversely, asking a static template or a static prompt to build out a full trip itinerary based on travel plans and past travel history would be a really big mismatch between the complexity of your use case and the technical capabilities that a prompt template might offer. Customization and all of these things in the output format and the overall design, it's going to be available across the board, but the customization of the scope of work and the scope of use only becomes more available as human engineers, human developers relinquish more control over the reasoning process being handled in these particular cases. So obviously with agents and multi-agent systems, they're handling a lot of the reasoning. Prompt templates, on the other hand, allow for a lot more human-based control, oftentimes coming in the form of shots and other types of context. But there are three additional considerations beyond this two-dimensional case that are really helpful in selecting the right model for your use case. The first of which being the scope of content and the scope of context required for your case. Training cutoffs with GPT and other big pre-trained models, that's always going to be a really big consideration, especially when you evaluate what's compatible with extensions to real-time search, for example. The second being human-computer interactions and just what role you want human feedback to play in a lot of this. Once constructed an agent or a multi-agent system, it's pretty rigid in how it generates output, and it doesn't often accommodate toward human feedback and any personal preference implementation. Prompt templates, they have a lot more tokens available, a lot more room for context in that area. And the third consideration being a big riff on multimodal inputs and outputs and what can be compatible with your particular case. Incorporating additional modalities beyond text and image is widely viewed as a huge frontier in the industry right now. And in a lot of cases, the large embedding models like GPTs and the other big players are really taking it upon themselves to be the trailblazers here. In the air travel case, this might be a really big development. You might want to incorporate LiDAR data tracking passenger flow. You might want to have videos for queue identification at security lines, concessions, customs. You might also want to generate unstructured negative sentiment labels around particular bottlenecked areas through topic modeling and unstructured sentiment analysis tools. As these diverse data sources are better democratized, the ways in which our LLMs interact with the world around us should really be contingent on meeting data where and how it lives. And it can be, this compatibility question, it can be domain specific. If you need Bloomberg, you have to use Bloomberg. There's really no way around it unless you go down the private LLM path, as we've covered in other webinars. But in most cases, there is a sense of choice involved. And with that choice, there are always going to be some trade-offs with compatibility. As shown here, with the large embedding models, the big players blazing the trail, it just so happens that these models have the greatest susceptibility toward measurable hallucinations. And to what degree we attribute these biases and hallucinations to human error or errors in our prompt design that could be better refined and optimized, and to what we can attribute them to just inevitable risks is just a matter of prompt training and refinement. And that's where this second evaluation component comes in. A lot of these harmful tendencies are byproducts of both model underfitting and model overfitting. And what do I mean by that? Model underfitting in the sense that domain-specific vernacular like acronyms, abbreviations, and synonyms, and other industry knowledge that extends beyond the scope of the public sphere are altogether uninvolved in most of the training process for these pre-trained models. And overfitting in the opposite sense. The World Wide Web, as we know, it's full of echo chambers. And in training LLMs on digital content and these digital conversations around the web, it can mean a much greater frequency of tokens, labels, and even information nodes altogether being assigned to particular concepts or phrases. This can lead to a lot of overfitting that directly influences the best next guess. So in many cases, some of these symptoms are just inevitable risks that we have to assume when using these pre-trained models. That certainly harkens back to that to train or not to train discussion we had in past webinars. For instance, we cannot possibly achieve a specific capability or characteristic of an LLM without clearly and concisely specifying what we want the LLM to do. But in doing so, there is a prevailing hypothesis in the LLM space called the Waluigi effect these days. And the LLM effectively becomes more susceptible to assuming the very opposite capability, the very opposite persona that we've identified. There's really no way around that. But many of these symptoms, other than that, are avoidable through some general principles in prompt engineering, which we'll cover in just a bit. Mitigating the model's tendency to, for example, take the first and last elements, or to always select the majority class, or favor frequently used tokens. It may just be a matter of either reinforcing the model with better context or reformatting the model schema itself. And more to come on some of those principles for best practices in just a few moments. So how does this look? How do we work toward performing much better in terms of response quality and working toward mitigating some of the biases that we can control? From an architectural perspective, 4 main considerations, 3 of which I'll cover here and 1 in just a moment. With the RAG system, as Gad just introduced, point of review from previous discussions, you're really adding very short but very informative context to LLMs. In many cases, this might come in the form of knowledge from public domain into private knowledge bases. But in other cases, it might be using something like a Google SERP API to initiate a live Google search and give the most up-to-date information on top of a pre-trained LLM with a cutoff. Directional stimulus prompting is another one. You can think of directional stimuli as general outlines for an LLM response. You can have a smaller LLM take the contextual input, in this case, flight information, and pull out the key concepts, maybe the key phrases, maybe just the general ideas that are mentioned in that particular input. Pass it back into the broader LLM that's really covering your downstream task. And finally, few-shot training. We're all familiar with this. Showing an LLM is always better than telling, as I will showcase a little bit more in just a few moments. LLMs are very, very good at seeing past gross shot construction errors, maybe spelling, grammar, syntax errors. And as we'll see in a moment, very messy query and response pairs can outperform even the most specific schema recommendations you can possibly conjure up. Second, labeling tasks like sentiment analysis. You might have positive, negative, and neutral. You may want a more evenly distributed or randomly sampled group as opposed to a pattern. LLMs are very good at detecting those patterns, and they're even better at accounting for those patterns in the responses that they generate. And finally, you don't just want to expend all of your tokens on a select few difficult cases. You want to make sure you're covering all of the challenging areas in a way that's exhaustive and representative of the types of requests you would expect from an end user. And architecturally, the fourth component is self-consistency. And this takes a lot of different forms depending on your use case, but you're using it to mitigate a lot of the inconsistencies in your responses by running the same prompt more than once. You'll need an LLM with a non-zero temperature here. You can collect a lot of different results using a lot of different logical flows. and ultimately decide on the final answer by a type of merging strategy. If you're using a labeling task, this might just be a majority vote. If you're generating a numerical prediction or a numerical response, you might want to take the average. It really just depends on how continuous your output is. This approach, it works really, really well for simple logical steps that can be identified as misses. So in this case, right, flying from Nashville to Atlanta. Nashville and Atlanta are in 2 different time zones here in the States, and the LLM incorrectly, in some cases, assumes that they are in fact in the same time zone. This is one hallucination that just by doing it over and over, the LLM will ultimately arrive at the answer if you take the majority vote, in this case being 11 a.m. So now let's move into general principles. Let's get down into the nitty-gritty of how we engineer our prompts. First and foremost, the more you can break down an overarching problem into smaller subproblems, the better. So rather than feeding in a massive data schema and a lot of other capability descriptions under one prompt, it's a lot more effective to identify the individual tasks involved in your LLM system and unify them under a broader, more specialized and diversified system. In this case, we're using a classifier LLM to direct traffic to specific agents or chains or prompt templates in this case. You're really opening up the LLM infrastructure to scale here. And in the event that you wanted these independent tasks to interact with each other down the road, or you wanted to expand the scope of your system, adding some more eligible labels under the umbrella classifier is a really, really easy lift in this way. Second, let's talk about shot quality. Certainly shot quality is very important, but just giving some is always going to be better than none. So much like trying to build a traditional machine learning model from scratch, allowing your LLM to make unnecessary assumptions from a massive set of embeddings, by the way, really tends to lead it astray, far more than just a few conceptual or formatting errors within your shot set. So here we have some spelling issues, we flip the labels around, but we're still getting the answer we're looking for. That tends to be the case across the board. Shot context over schema context. Showing is always better than telling, especially in cases with really complex data structures. Adding written meta features and metadata is either really unhelpful to the task or a huge waste in the tokens that you have available. Shots will always give you a clearer and much more concise picture of where the key nodes of information are, how they're related to each other, and how they would best factor into the output you're looking for. Now let's talk about positive and negative instruction. This one is actually really fun. In this case, instructing the LLM on what to be and what the output should be is far more effective than trying to prevent certain attributes or trying to tell the LLM what it shouldn't be. In this case, with our airport example, mentioning no longer than 12 steps actually encourages the LLM to always give you 12-step guides, even if the guide itself should be really, really basic. User frustration could result from this pretty easily. You're getting a lot of unnecessary steps as filler, and that can happen. It does happen. Let's talk about personas. When you try to articulate to the LLM what its role should be, you may want to encourage it like a friend. You definitely don't want to give it an inflated or impossible degree of intelligence. It would hence force its hand to be a little pretentious, definitely a little bit overwhelmingly specific, and altogether unnecessarily articulate in some areas. Again, with user frustration, you're always looking for more concise, more clear output when that might be provided. All in all, with this general structure, with this general architecture, you're articulating what the role of the LLM should be, what the capability under that role should look like, what options for output are available. So maybe some examples, maybe some few shot training if you have it available, but most importantly, an option to opt out. LLMs have quite the ego problem these days, and the best way to maintain its transparency and its explainability, maybe mitigate some hallucinations, is by clearly assigning an out, a confidence threshold of sorts. It can either be regulated by the LLM itself, in this case, or you can be human in the loop. But by and large, being able to generate an option to go to human support or consult ChatGPT for more general, unrelated requests to your particular knowledge base, it's always really, really helpful. And finally, a quick discussion on system versus user. controls. Being able to set constraints from a system perspective will almost always override any requests made by the user. So in this case, we're looking for a very simple 1-paragraph summary, and look at what the user wanted, a 2-paragraph summary. It will always override any of these requests. It's a really, really light and really easy point of entry into guardrail management, protecting against hallucinations, protecting against code injections, any other nefarious requests around deleting tables, modifying documents, or deleting them entirely. So using this system messaging alongside the user and assistant we're all familiar with is generally really, really helpful for personas. I will skip on these two. I certainly have some thoughts, but would like to take questions at the end, or feel free to drop in the chat. We'll be providing these slides as well. And we've covered a lot, even without synthetic data generation, in design and development and evaluation and refinement as a whole. It really doesn't tell the full story. There is a massive field in the area of prompt optimization led by this test-driven development. It's critical to ensure that our prompts maintain both performance and relevance in the market as a lot of these capabilities mature. Prompt optimization really tends to pick up where this evaluation framework left off. So with that, I will pass it back to the TensorOps team. We can talk about some prompt techniques.
Nice, thanks. So that was an amazing overview. I think when I kind of think of LLMs, I'm trying to think of them as like the language in which you code to LLMs. And we actually prepared a poll, and I wonder, where do you use prompt engineering when building LLM applications? So this is a multi-choice. You can select more than one answer, and I'd be interested to see which parts of the architecture are you using prompt engineering for. Let's see some answers here. Oh, it's changing by the second. Nice. Okay. Now, like, we have 40% participation. I'll give it 5 more seconds to give your votes. Okay, and we close the poll. Now, nice. Maybe you can share the results of the poll and show you that, well, unexpectedly, actually very expectedly, sorry, most of you are using prompt engineering when doing generation and prototyping. But what I find interesting is at least 50% of you are saying that you use prompt engineering also as part of the retrieval. So I think in this way, in this part of the webinar, it's going to be mostly Miguel talking, and we're going to deep dive into actually how to apply some design patterns in prompt engineering, part of the things that David spoke about. And we're going to see it in two main architectures, and which are chains and agents. When I think of chains, I think about them as data pipelines driven by AI. So you're taking source of data, you're doing some transformation, and you're passing it to the next phase until you get the end result that you want. You could do it with SQL, you could do it with traditional Python, or you could do it with AI and LLMs. And chains is like, you know how AI engineers love to invent their own words for everything. So basically chains, in my opinion, are nothing more than data pipelines driven by AI or LLMs. When it comes to agents, I kind of think about it in a bit of a different way. It's when there is a little bit more autonomy for this chain to decide on the next phase. And Miguel is going to walk us through several implementations of prompt engineering for chains and then for agents. So chains, you all know them. LangChain, very familiar one. Basically calling the LLM, getting a result, and then passing the outputs to the next one as an input until you get the final result that you want. Very, very common architecture or very common practice in designing RAG systems. And when you think of these LLMs, when you think of these chains, one thing that you want to do if you're designing a data pipeline is to control the outputs and the inputs, right? Because you're designing a pipeline and you kind of want to know that the next step of the pipeline will have a consistent input coming as the output of the previous stage. And if the previous stage is an LLM, then you might have inconsistency. So Miguel is going to speak about techniques for controlling the outputs.
Yeah, so thank you so much, Gad, for the introduction and the overview. So about controlling output and techniques for that. First off, we have zero shot that you probably know about, in which you intend on the LLM perceiving your goal and you assume that it will know what you want and give you an output. But with few shot, you give it some examples. Now, what these examples are a way for you to give it some direction, how it should behave in certain edge cases and how to steer it in the right direction. Now, you can also make it output in a certain format, say in JSON, in SQL, and this is the way to do it. I hope this answers your question, Gad.
Yeah. So the next one is, if I'm thinking about like data pipelines, then like the most basic data pipeline is, I'm getting data in, doing some computation, and then getting data out, and then doing another step of computation. So controlling the inputs and the outputs is really important. What happens when I want to do some more complex logic within each step?
Yeah, that's a great question, because with LLMs, we're always wanting to do more. And we know for a fact that they have quite some difficulty with math problems. So here we have one. So say I purchased the ticket for $200. I was charged an extra 15% and I want the refund. Now with basic prompting, you just ask it for the final answer and it needs to understand how much should I get as a refund. It says I need 15, which is wrong. So let's try to perceive this how a human would. When you're faced with a math problem, you usually tend to think step by step. Maybe you write it in a piece of paper, maybe you just think in your mind. So by us telling the LLM to do exactly that, let's think step by step, it prints out its thought process, which adds some transparency and ends up getting the right answer of $30. So this ends up increasing the accuracy. So what is this chain of thought? It's exactly this. You get an input as a prompt, you make the LLM give out its thought process, and then converge all of that thought process into a final answer. This could be used for many things. We gave out the example of mathematics, but it can also be used for common sense reasoning, question answering. In general, it's a core idea and central to the prompt engineering part. So back to you, Gad.
Nice. So I really enjoy looking at this because I think it starts to get like a sense of how can I build better apps using prompt engineering. So it's not just acting naively and just like putting the prompt I want at every step. I can be aware of the app that I'm developing. I can be aware of which step or which functionality or which model is this step responsible for. And if I want more consistency, then I can maybe use a few shots. And if I want more accuracy in the complex for a more complex maybe calculation, then I can use chain of thought. What about increasing the quality of results through prompt engineering? What happens when I'm getting a result and very often it's not exactly what I wanted it to be? I want a blog post or I want an answer and it's not exactly as I wanted it to be.
Yeah, so that's a very common problem that we have in our hands. And so let's bring into the table a problem about common sense reasoning, the question of common sense. So we can use a technique known as general knowledge prompting. What this does is a technique to try to extract knowledge from the network that it gained during training and make it print out its knowledge before answering. So it's, again, the same thought process of think before you answer. So you have the question, you make it print out its knowledge. Say in this example, the user wants a flight of 2 hours from New York to Portugal. But by it printing out its knowledge, it understands that, well, typically it's 7 to 8 hours. So when it gives out the answer, it can not only tell us that it's impossible, but it can tell us why. So it can really help us increase the quality of results. Now, picking up another use case, and the common one, which is, well, summarization. LLMs are known to be so useful for summarization. So many times we have a big article and we just want it to give us a summary. So what we say, oh, please summarize it in 4 to 5 sentences. We just give it a simple prompt. Now the summary it gives is okay, but it's not the best. It has a lot of boilerplate. It's not too rich. So this is where chain of density comes in. Now, this is a recent technique which aims to provide short, concise, and dense summaries, so rich in information. What this does is it creates summaries iteratively. So first off, we ask it to identify 1 to 3 entities, create a summary of a given length, like 5 sentences, and then identify which new entities it could add, which new relevant entities it could add, and insert them in that summary. And it does this over and over, like 2 to 5 times, and in the end we get a very rich and dense summary. So what does this look like in practice? So let's look at an example. Okay, perfect. So on the left, we have an example from the original paper of chain of density. And on the right, we have an example about a ticket of a person which is going to fly, and it wants a summary of that whole PDF with the most important information. So in bold are the entities which were extracted. And at first, we can see a summary, which despite having some information, has a lot of boilerplate and not so relevant stuff. But we can see below it another summary, which has in red the added entities, and below that, an even denser summary, which has much more information. So here you can see what's the benefit of using this kind of chain. So yeah, I think, and I hope that answers your question, Gad. So back to you.
Yeah, so basically saying chain of density is a way in which, so very often like LLM, you're doing a call to the LLM with some kind of prompt, you're getting an answer back. A lot of the volume of the response is being used to return filler words or some connecting words, not necessarily all the information that you want. And chain of density is kind of a way to make your answer more dense in terms of the knowledge that it has. Right? So like, of course, the next thing that everybody would probably ask about is how would you reduce hallucinations? And we're still in the context of chains. I don't want to speak yet about hallucinations of agents, but we're kind of getting into complexity to agents, as you can see.
Yeah, that's obviously a great question and big problem in this LLM world. So this is where we have chain of verification, which is a recent technique that appeared, which also aims to make the LLM think like a person would. So from a prompt, from a question, it makes the LLM give an initial response, a pretty basic response, but then it tries to verify that response. So what questions will a person make to verify something is true? It plans out these questions, answers them independently, and then aggregates all of this into a final answer so that the final answer can be verified. So let's look how that is in practice. So an example of this would be taking this query. I want a flight from Madrid to Paris on the 20th, okay? The LLM gives a baseline response, pretty simple. Here are some flights that meet your demands, flight 1, flight 2. Okay, and then we ask the LLM, how do you verify this information? So it needs to see when was it scheduled, if it is from the correct cities, etc. It then executes these verifications independently and gives out a final answer. And if you notice it, in the final answer, only flight 2 is there. Flight 1 is missing. Why? Because flight 1 was an hallucination. And it caught this hallucination and could maybe get other types of scenarios and edge cases. So this chain of verification is an additional step which can really help the model be more robust.
I kind of love this example, right? What I love about this one, there is the concept of like gaslighting your LLM, right? It's like it gives you an answer, and then you're like, are you sure that's the right answer? Are you sure that you're sure that that's the right answer? And here you're not just gaslighting your LLM, you're actually making the LLM gaslight itself. It's like, what would you ask yourself in order to make sure that you have the right answer? Right? So basically, this is chain of verification. Like you're doing again and again and again, you're creating a chain in which you're asking the LLM, what would you do to verify? And then once it gives you the answer, you use it against it, right?
Yeah, exactly. I think that's a pretty great summary. And with that said, we go on to the next core idea, which is confidence, which David also talked a bit about, which is how do we know that the model has confidence in its answer? Because this is very important for us to interpret it. Now, one of the key concepts is uncertainty, which is the number of unique answers divided by all answers. Another concept can be token likelihood, if we do have access to it, because some service providers do not give it. And there are more concepts. But for now, let's focus on uncertainty with our next technique. So remember few-shot prompting, which we talked about before? Active prompting highly correlates to that. What it aims to do is to find the best examples on few-shot prompting automatically. What best examples would help steer the LLM? It does this by first picking up the few-shot questions, getting them answered, calculating the uncertainty for each, and asking a human to label the most uncertain questions. Then by having these labeled questions, which were supposedly harder, they can be used as examples. And with this, I think we will pass on to you, Gad, with one of the most exciting areas, right?
Yep. So I see that we have 15 minutes left for this webinar. We don't want to overflow too much. So we prepared some more slides, and they're all going to be available. But I think it is important to speak at least about the first technique of agents. So when we're talking about chains, this is the more traditional data pipeline, as I mentioned, approach. It's a new data pipeline in which the processing unit of the data pipeline is not Python code, and it's not Spark or Scala. It's not SQL. It's actually an AI. And many of the techniques are meant to guarantee that we compensate for the generative part or the stochastic part of the LLM by introducing some more stability, right? Because on the one hand, you have like creativity that is provided by the AI, and on the other hand, on the one hand, you have like the creativity, and the other hand, you actually want to kind of like tone it down and make sure that you have more stability, so the pipeline does what it's supposed to do. Agents are one step going wild. These are cases in which you let the AI decide on what's going to be the next step, kind of giving the chain more another level of independence. So agents, like I said, they are not a sequence of events like a chain, but rather an autonomous way of the LLM to decide on what's the next step. Very often you give them access to tools and you call it functions maybe sometimes, a way to bring in information from another place or deciding to do some action and then wait for the results. And they're very, very useful in doing more complex tasks. So for example, like chatbots. Miguel is going to talk about this technique from prompt engineering that is very, very typical for agents.
Exactly. So tree of thought is one of the most known techniques. So here we have an example. It pretty much, the LLM intakes a question, can I take my dog on the flight? And it automatically generates several responses. So it knows that it needs to know more information. What's his breed, his weight, his color. Then you evaluate automatically each of the answers. Now this could be done by another LLM, by some sort of rule, mathematical rule, etc. And then you pick the answer which looks the most promising. So you could either follow typical algorithms or just pick the one which has the highest evaluation and follow through it, thus giving the tree-like structure, which we'll see next. So having the tree-like structure, as we can see on the right, also allows for backtracking if needed, and other types of tree traversing techniques, which are fairly known and widely studied. So this is an agent which can be highly versatile for many scenarios. So
Okay.
yeah.
I think that given the time, I would like to leave some time for questions and also for a short demo that we prepared in order to kind of like show you guys and girls how we actively do prompt engineering. And I think part of the discussion is a little bit about the tool themselves. So Miguel, I think you prepared a small like a demo for us, right?
Exactly. So this is how all of this actually materializes into an easy to use platform. So here we have LLM Studio. It's an open source platform, and it helps us test out different results and really see how each prompt and each prompting technique goes on and materializes as an output. Let's see
That's
if the
the
video
yeah,
decide to load.
that's the first time like you're preparing a video in order to save yourself the
Yeah,
issues
oh
with the
well.
demo, and then
Then it
like
decides not to load.
yeah, I think
Here
it
it
loaded
is.
now.
Okay, great. Now we have it. So exactly. On the right, we have the parameters, which you can change. Then we can also exchange between different models. And so let's try out one of the prompts about flights. So if a bag and a fell luggage was lost, do we want a human to be contacted? In this case, the LLM outputs yes. And we have the logs on the bottom. However, let's say that in our scenario, we want a different kind of behavior, and we actually want it to deal with that on its own. So it should answer no. By giving it examples where we say that when a luggage is lost, it should answer no, it steers itself in that direction. So we can see how that impacts the answers. Now, picking up a math problem, like similar to the one we had before, we can also see how each prompting techniques affect this. So by telling it answer with just the final answer, it gives us what should the refund be? It says 24. That's the wrong answer. That's not actually correct. The correct answer is 6. By just letting it go on its own, it then does some thinking process which is not too complex and arrives at 40, which is not correct either. There's one more technique which we explored earlier. Let's think step by step. And by doing this, it actually constructs a thought process, a complex thought process, and arrives at the correct result of 6. So we can really see the impact of this kind of technique. So now let's look at the bottom where we have logs of all our previous experiments. We can restore them so we can mess with them and go over some details. We can export them to a CSV, for example, to share them more with ease with friends or coworkers. And then we have the compare module, in which we can easily send a prompt and compare the outputs of different models. So for the same prompt we used earlier, we can see how each model responds. And we can see that only GPT-4 actually said 6. So it's the only one who knew it out of the bat. But if we use our well-known prompt, let's think this through, let's think step by step, let's see which models actually get it correct. So each of them ends up thinking, and we can see that GPT 3.5 got there, and GPT-4 also got there, and Text Bison. But we see that Chat Bison didn't. So this is an easy way to compare different models.
All right. So I think that what you're seeing here is how impact you have. What's the impact that you can have when you are when you're using the correct type of prompt engineering for the correct problem, right? Because in these cases, I don't know why I cannot like go back to full screen.
I think it's fine if you leave it on the next one because the amount of questions that we're getting on where is this, I'm answering it multiple times. So why don't we leave it here so everyone can get also to the LLM Studio at the same time?
Yeah. So basically what you're seeing here is an open source tool that we are developing. I know that there is plenty of other projects. Most of them are commercialized. TensorOps developed this tool called LLM Studio. You can scan the QR or just go to llmstudio.ai and it would take you directly to our GitHub. We think that for development for the IDE, we need to be open source. Like for data scientists, Jupyter Notebooks were the tool that made data science so popular, democratized the domain. So we think it's important to have an open source tool which is not commercialized, that is going to be part of the community and come from the community, and people can contribute to it and basically democratize LLMs. So the way we think of LLM Studio is both an IDE, but also a way to take LLMs to production. And I think you can see the contribution guide. It's still in its diapers, I would say, but you can definitely go and make pull requests and help us out develop this tool for the community. Okay, we kind of like ran closer to the end of time. I wanted to wrap this up and then leave some time for questions. I think that when I developed some software, both like mobile and backend, and then did some machine learning, and now LLMs are very popular. And what I can say that's different between developing LLMs towards the rest is that the element of stochasticity is extremely higher in LLMs. So you hear about like the traditional process of developing AI, which is you do a lot of planning and a lot of iteration until you really, really fine tune exactly what you wanted. And with LLMs, you kind of embrace this stochastic. Sorry, there's stochastic behavior. This is from Azure when they're describing the process of developing prompts. So you see that iterative process going again and again. But what I would emphasize is that the experimentation is really important. So the experimentation part in which you move fast and break things is really, really important when you're developing LLMs. And it's mostly about trying out these prompt engineering techniques and making sure that you have the right things. So don't plan too much. Another example to that is that when people develop ChatGPT, like when OpenAI developed ChatGPT, they did not expect many of the things that people would discover. So you can be theoretical, but many of the things are just going to be revealed as you go. So do know these techniques and do know that chain of thought exists and chain of density exists, but don't overfixate on trying to build the right prompt from the beginning or the right pipeline from the beginning. Try a lot of stuff, break things, make comparison, embrace this stochastic behavior of LLMs. That was the most. We have about 5 minutes to answer questions. So
yeah, so there was a bunch of questions in the QA in the chat as we go through. Guys, we also had like 3 different techniques that we didn't manage to cover, but anyone who wants to stick on after the hour, we can go back and cover those 3 advanced agent techniques. But let's answer the questions here. So we had a question like pretty early on for an anonymous attendee. I would give you the credit, but you didn't tell me who you are. And the question was, why would extra leading or trailing white spaces in the input affect the output of an LLM? So I think, David, this one's probably a little bit up your alley.
Yeah, I can answer that one. Short answer, it all harkens back to how the model was trained, right? So trailing white space or leading white space would effectively shift the embedding vector representation. So the tokens would be effectively different. You would hope and you would expect a well-trained model to treat those embeddings similarly and that they would be very close in proximity. But there are probably going to be some nuances in terms of the nearest neighbors of those embeddings and how they're represented. So that particular prompt or that particular context that you're inviting into the prompt would be fundamentally different. So as you would hope, again, with big, large embedding models, you'd hope they would be receptive to that type of difference, that type of change. But some of them are a little bit more case sensitive than you might hope for. So.
Okay, so this one's for Gad. It's like halfway philosophical, halfway technical. So Charles is asking, are prompts here to stay or will they be subsumed as the models go and get better?
Oh, if only I knew. If only I knew, I'd be really rich. I think that what you see is that perhaps the way that you're going to generate prompts is going to be more and more automated and more controlled. So I do think that prompts are at least here to stay with LLMs as the way to interact with these models. Not necessarily a lot of manual prompt engineering is going to be done. The kind of parallel world that I'm thinking of is what happened with machine learning. So and it's kind of like hyperparameter tuning that came and replaced a lot of these like expertise in like how to prevent random forests from overfitting, right? So eventually, like you're using Optuna and you're just like trying out kind of automatically with sophisticated search algorithms for the best parameters in order to get what you want out of your random forest or XGBoost. So I do think prompts are still going to be significant, but you're going to see more and more techniques to get them automatically and maybe having assistance of another smarter LLM to get what you want. But that's like a guess. And if I really knew the answer, I would be probably doing something really smart with it.
Okay, so we have another one from Harpreet here. Hi, Harpreet, by the way. Okay, and this is a loaded question, so it's open to any one of you three that wants to take it, but I know that there are strong feelings associated with this question that go deeper than the question itself. So the question was if there's an implementation for chain of density in either LangChain or Lambda Index. I think you guys have a lot of thoughts on the two, and it's probably going to touch on that also a little bit. So I think
Yeah.
Miguel is jumping in here.
Yeah, I can take it. I mean, these techniques, for example, chain of density and even chain of verification, they have probably not a lot more than 1 month. So there hasn't really been a lot of time for the libraries to implement them. So most people are using them by hand. But if you look at chain of density, it's actually just a prompt. You can go to the paper. We can link it at the end. Just copy it, paste it in LLM Studio, run it, and you have a perfect summary.
Sorry, I was on mute there. So Francesco is asking, is the verification done via RAG from reputable sources? Not 100% sure to which part that is referencing. Miguel, does that ring a bell? Okay.
Yeah, I think if I'm not mistaken, you're referring to chain of verification. And yes, ideally there you would go to reputable sources because you're not going to verify it with something which you're not too sure about, right? That would not make sense. It would just add more probability of the network going where you don't want it to go. So yes.
Okay, awesome. Okay, so let's go back to the 3 agent techniques that we didn't manage to cover, because I do think that they're interesting and we wanted to cover some of like the more up and coming stuff that doesn't get as much attention today. But for anyone asking about the links to the original papers and so forth, it's all within the presentation. So when we send out the follow-up with the recording, you will also get the presentation itself with all of the links in there. So don't worry, you'll get everything. We don't leave anything out. So let me pop up the presentation, and then Miguel, you can take us through the slides that we haven't gone through yet. 1 second.
Yeah, let's go back to the Auto AI slide. Yeah. Okay, perfect. Here, we're perfect. So we were talking about agents, and one important thing about agents is that they have more autonomy. But how much autonomy should they have? And React is an example of an agent which is pretty much the most autonomous it can be. Think of a human. When you say to your coworker, oh, I need help with this, I need you to do this project, he doesn't just try to do it once and then stop and give you the result. No. He iteratively goes back until he has a refined answer, and then he gives it to you. That's what React is, reason plus act. So given a query, I want to reschedule my flight from Madrid to Paris from 10 to the 12th. It first gives a thought about that. I need to search for flights. Okay, so how do I act on that? Search for flights. And that could be using a tool, using RAG, using whatever. observation, it gets a flight, and always does this: thought, action, observation. Second thought, based on the last observation, I need to check if it has availability, and then third thought, no flight available. So here there are two options. When there are no flights available, you either go back to the user and say no flight, or let's try for similar flights in similar dates. And this is where React, and as we see in this diagram, goes in, where it's a loop. And it's the React's job to decide when to break out of that loop. Then there's the autonomy part and the extra autonomy. So yeah, I think that's the core idea about React. Now, if we have time, we can go on to the next technique. Yeah, perfect. So about the problem with React is that this iterative cycle tends to take some time. So it increases latency and it has huge costs. So the amount of tokens produced are huge. It has huge costs. And it's also prone to failure when tools fail. So then we have reason without observation. So here we have the diagram. We first input a prompt. It goes through an LLM which plans ahead what it's going to do. And each plan, the output of each plan goes as input to the next one. It then gives these plans all set to a worker which executes them, and a solver which aggregates them. Now, planner, worker, and solver are all LLMs, aggregates into a final answer. Now, what this does is it gives a result which is accurate, but with much less tokens. So around 60% cut in token usage. And we can see an example of this real quick, just so it doesn't get too abstract. So if we look here, the same query where the user wants to reschedule, and the planner makes 3 plans immediately. I need to search for flights, I need to check for availability, and I need to check if price is similar. The worker then goes get the evidence, so the outputs for each plan. It does it, and then the solver aggregates all of this into a final answer. And it says rescheduling is not possible. And do notice that here it does not go back into this loop because Rewoot does not have this loop. So it's one of the main differences. And I think we can stay here because probably, it's a final slide, so maybe I can cover just the final slide and then we'll get back to anything else we have. So reflection is exactly about dealing with hallucinations. These kind of agents hallucinate all the time, and one small step and one hallucination can drive them in a trajectory which is completely opposite to our initial goal. So this reflection framework is about, let's look at the same query, rescheduling the flight. Action number 1, which was planned, check for flights. Action number 2, change user to new flight. Do notice that here it had no existing flights, but still it did try to do the action because it was already planned. There's an LLM which evaluates the situation, determines that it was a hallucination, and then another LLM which does a reflection over this and sees why. And it actually searched from Paris to Madrid instead of Madrid to Paris. So then it corrects its trajectory and does it again. And this is a way to keep correcting the trajectory that the agent is going to think on. And yeah, I think this way we covered all the techniques that we want to do. Oh, you're muted, Maura. Yeah.
Sorry.
Perfect.
Okay, so let's hop on all the way to the end and just like wrap this up. So we covered a bunch of things today. We did do a couple of skips here and there, but you will get the slides at the end. So first of all, if there's something in the slides that you want to go more in depth on, just feel free to ping us. All of our contact detail will be shared in the follow-up. So ask us any questions that you have, and we're happy to answer them. But there's 3 core things that we covered here. So first of all, in terms of limitations, from what we've been doing up until now, what are the best practices as we know them? And as you saw, yes, they're rules of thumb, but it's a good way to start translating these examples that sometimes to us can seem like very random into, okay, this is how I should be building my system syntax in order to achieve the results that I want at the end of the day. Miguel and Gad also took us through architectures, everything that's out there really that we want to understand, how we should be looking at these solutions and selecting the right type of technique in order to do what we want to do. And the last thing, which I think both for everyone here that wanted to talk in regards to prompt engineering, the last one really is key, is this shift in mindset as practitioners, that we kind of need to break out of this habit that we have from more traditional machine learning, where we invest a lot in collecting data and cleaning data and going through the entire first part of our cycle. Is with LLMs and with prompt engineering, the heavy lifting shifts more to the right, more to closer to what we're actually doing in production. So being able to experiment there, being able to rapidly understand where we're failing and use that as a leveraging point for further optimization is really a shift in mindset. And we need to adopt a better bug-driven development approach here, and not, try and flesh out these fully functional architectures and systems. But first of all, quick and dirty, let's get there, let's see if it works. And from there on, once we have, that initial validation, then we can go back and start building out the systems as as they should be, from a more engineering perspective. And Miguel showed you a bunch of tools. There's all kinds of different open sources and commercial tools on the market that you can use to get yourself there. Obviously, we're all about open source, so we do want to put that a little bit more front and center. And with that, we're going to wrap. I think we answered all of the questions, but we're really over time at this point. So if we didn't, I'll go back through the chat and the QA, and we'll, in the follow-up, try and address any questions that we didn't get to. And we'll also share all of the contact details, so feel free to reach out to us and to talk to us with any questions. And we'll keep your eyes out, because we will also be sharing information on workshops that we will be hosting around this topic. And we'd love to invite you and your organizations if this is something that you want to dive deeper into. So with that, I'm in shock that all of you actually managed to stick another 15 minutes, so a good portion of you stayed. And thank you to all of our speakers, one of which had to leave us a little bit earlier. But thank you, Miguel, thank you, David, and thank you, Gad, even though you are not here listening. And we will see you all next time. We haven't quite yet discussed the topic also, so it's open for grabs. So if anyone in the audience who's still listening has something that they absolutely want us to be covering, it can be LLMs, or it can be machine learning, let us know, and we will look into it and see if that may be the next thing that we will be covering in our webinar series. So with that, goodbye, good day, good evening, good night, depending on where you are in the world, and we'll see you all next time.